Hi, this is Jason Molesky. In this example, we'll take a look at transforming with logarithms. Let's return to the fishing tournament from the previous example. Our goal remains the same. We want to find a model for predicting the weight of an Atlantic Ocean rockfish from its length. We still expect a power model of the form weight equals a times the length cubed based on geometry. Now earlier we transformed the data in two ways to try to achieve linearity. First, we cubed the length values, and second, we took the cube root of the weight values. This time, we'll use logarithms. Now, let's say we took the logarithm base 10 of the values for both variables. Some computer output from a linear regression analysis on the transformed data is shown below. So as you can see, here we have plotted the logarithm of the length versus the logarithm of the weight, and we see a fairly linear pattern. We also plotted the residuals, and we see no real pattern, fairly random scatter, and then we have our regression analysis output for Minitab. Now our problem is, based on the output, explain why it would be reasonable to use a power model to describe the relationship between the log of the weight and the log of the length for Atlantic Ocean rockfish. Well, if a power model describes the relationship between two variables x and y, then a linear model should describe the relationship between the log of x and the log of y. Now the scatter plot we just saw of log weight versus log length does have a linear form, and the residual plot showed a fairly random scatter of points about the residual equals 0 line. So, based on these two criteria, a power model does seem reasonable here. Now next, let's give the equation of the least squares regression line and define any variables we use. Now again, looking at the Minitab output, we're going to want to focus on the coefficient column. Using the values negative 1.899 and 3.04, we can generate our equation. The predicted logarithm of the weight will equal negative 1.89940, that's our constant value, plus 3.04942 times the log of length. 3.04942 is the coefficient for log of length. Now for some additional practice with transforming with logarithms, try exercise 35.